everybody. You know that parametric equations define movement along a path. So let's say that I have an x of t equation, and I want to find the y of t equation that will create motion along a specific path given by an equation like this. So here I've gone ahead and plotted it for you by plugging in x values and finding the y values. So what's interesting here is if you think about the input and the output, I'm trying to write an equation where I plug in a time, and it's telling me a y value along this path that I'll be at that particular time. So it's hard to imagine how would you just do that, pull it straight out of your mind. But you could do it if you thought about specific time values. So for example, let's ask, where's my y value when time is 1? Well, it would be a two-step process. At time 1, I can figure out my x-coordinate by plugging it into the x equation. So I'll have 2 times 1 plus 1 is 3. And then I could figure out my y-coordinate by taking that x-coordinate and plugging it into the path I know. If I plug the 3 in for x here and here, that'll let me calculate the y-coordinate. Well, okay, notice here that I haven't written y with function notation. I just said y equals this stuff. If you think about what the input is to our equation, it's x. So really, as a function, I'm imagining y as a function of x here. But I want y as a function of time. I said we did it with a two-step process. I have a time, I plug it into an x equation, and then I take the x value to plug in to the y equation. Well, instead of doing that each time as a two-step process, let's do it just all in one step. So I'm going to write here the same equation, except I'm going to leave a blank wherever there used to be an x. And instead of plugging time in here and then taking that number to plug in for x, let's just do it all in the same step. I'll write 2t plus 1 there where x used to be, and 2t plus 1 here where x used to be, because that's how I found x. So now you can imagine it really is the exact same process. Let's do it again, find the y-coordinate when time is 1, only using this new equation. If I plug in 1, I'll get 2 times 1 plus 1 is 3. And it appears right where I plugged 3 in before. If I plug t in over here, I'll have 2 times 1 plus 1 is 3. And it also appears where the x-coordinate of 3 was before. So instead of plugging it into x, taking that number and plugging it in here, I've just taken the equation that I used to find the x values and put it right where those outputs would have gone. If you don't recognize this as composition of functions, that is exactly what composition of functions is. What I've done is I've taken my y of x and I've composed it with my x of t. So now if I plug in time equals 1, this gave me my x-coordinate, and then that x-coordinate was input to my y. And so that's given me now a function that tells me y, where the thing I really plugged in was time. So it's sort of like you can think about it as a unit conversion from time into x, and then x into y, happening all in one step, time into y.